Well, hello, I'm Zazil Santizo, and it's an honor and a pleasure to be here. First of all, I want to thank Violet and all the organizers for their support, and congratulate Professor Huerta for his 65th birthday as well. So, as you can see, I will talk about the results of a study of the one rotational resolvable 25241 designs that were classified by Professor Marco Bratti and Suani in 1999. And the embeddability as maximal arcs of degree 4 in a projective plane of order 16. So this will lead us to the main result of the presentation, that exactly one of the 22 one rotational 5241 design is embeddable in a plane of order 16, being the Sargisian plane, PG216. So in order to do that, I will briefly recall and introduce some of the definitions and results. So, first of all, a 2VK lambda design B is a pair of point set X of size B and a collection of K subsets B called blocks, such that every pair of points is contained in exactly lambda blocks. So every point of X is contained in R equals to lambda times B minus 1 over K minus 1 blocks, which is the occurrence number. And the number of blocks is B equals to V over K times R. And when V is equals to V, we say that a design is symmetric. And also, when lambda is equals to 1, we say that the design is a Steiner design. In addition, a projective plane of order Q greater or equal than 2 is a symmetric Steiner 2 design with parameters Q to the square plus Q plus 1, Q plus 1, and as you know, lambda equals to 1. So, an affine plane of order Q greater or equal than 2 is a Steiner 2 design with parameters Q to the square, Q1. Now, let's define what is a parallel class. A parallel class of a 2VK lambda design is a set of V over K pairwise disjoint blocks. And a resolution of a design is a partition of the collection of blocks into R disjoint parallel classes. So we say that a design is resolvable if it admits at least one resolution. Okay. Now let's jump to the maximal arcs. To study the relation between maximal arcs and Steiner designs, it is necessary to define what is a maximal arc. So a maximal arc, a maximal MK arc is in a projective plane of order Q equals to K times S. It's a set of M equals to Q minus S plus 1K points that meets every line of the projective plane in either K or 0 points. And respectively, a dual arc for the dual arc. So the set of, let's define A as the set of lines of the projective planes which have no points in a given maximal S times K minus S plus 1 times K arc, such that determines a dual maximal S times K minus K plus 1 times S arc, a perp, in the dual plane. So here are the known maximal arcs with 1 less than K less than Q. So by Denniston, we have that the Sargisian plane, the Sargisian plane of order 2 to the M contains maximal arcs for every K equals to 2 to the I, where I runs from 1 to M. Other constructions are given by Gas in 1974 and 1980, Hamilton in 1994 and 1995, Hamilton, Stoichev, and Tonchev in 2000, Mathon in 2002, Hamilton and Mathon in 2003, Leclerc, De Winter, and Meth in 2011 and 2012, and just recently HESEC in 2017. Okay, and by Ball and Blockius and Matsuoka, we have that maximal KRs do not exist in any distribution plane when the order is odd. Its order is odd. So now let's jump to the resolvable Steiner design from a maximal arc. So we want to know when a Steiner design is associated with a maximal arc. So let P be a projective plane of order Q equals to S times K. And then we have the following. The non-empty intersection of a maximal S times K minus S plus 1 times K arc, or A, with the lines of the projective plane form a Steiner 2D design D with parameters S times K minus S plus 1 times K, K1. And respectively, the dual S times K minus S plus 1 times K arc, called or named A perp, is the point set of a Steiner 2 design D perp, or the dual design, with parameters S times K minus K plus 1 times S, S1. And we have the following result. The points of the dual arc determine a set of S times K minus K plus 1 times S, resolution of T, and the points of A determine a set of S times K minus S plus 1 times K resolutions of the design, of the dual design associated with the dual arc. And then we have the following property. Every two resolutions of T, or the dual, respectively, share one parallel class. And so, necessary and sufficient conditions for resolvable Steiner 2 design to be embeddable as maximal arcs in a projective plane were proved recently by Tonchev in 2017. So we need to define the following. We have the two resolutions of a 2 design with parameters S times K minus S plus 1 times K, K1, say R1 and R2, are compatible if they share one parallel class, and the remaining parallel classes share at most one block. More generally, a set of M resolutions, let's say R1 to Rm, is compatible if every two of these resolutions are compatible. And let's know that a Steiner 2 design with parameters S times K minus S plus 1 times K, K1, associated with a maximal S times K minus S plus 1 times K, Kr, call it A, in a projective plane of order Q equals to K times S, admits a set of S times K minus K plus 1 times S pairwise compatible resolutions. So we have the following result. Let S be a set of M pairwise compatible resolutions of a 2 design D with parameters S times K minus S plus 1 times K, K1. Then M has the following upper bound. But when the quality holds, and the quality holds if and only if there exists a projective plane P of order Q equals to S times K, such that the design is embeddable in the projective plane as a maximal S times K minus S plus 1 K times K, K arc. Okay. Also, in 2017, HESEC, Wagner, and Tonchev found that the two different sets of 52 compatible resolution of the two 5241 designs associated with maximal 52 4Rs lead to two non-isomorphic planes of order. Oh, sorry. I was reading with that. Planes of order 16. Yes. And by Ball and Blockus in 2002, we have that the projective plane of order 16 contains exactly two projectively equivalent maximum 52 4Rs, both of Denison type. And I was speaking about this, I'm sorry, I confused myself. So, okay. Now, let's go to the point. So, we say that one rotational design is a 2vk lambda design. A 2vk lambda design is a one rotational design if it admits an automorphism of order v minus 1. That is that it admits a bijection on its points, leaving invariant its resolution. And by Marco Buratti and Suani, we have the following result. There exists exactly 22 non-isomorphic resolvable one rotational 252-4-1 designs up to isomorphism. And now the question is, which of the Buratti-Suani 252-4-1 designs are embeddable as maximal 52-4Rs in a projective plane of order 16? So, this is the algorithmal outline. I construct the incident matrices of the 22 one rotational designs. Then, by using Magma, I compute all parallel classes and resolutions of each design, Fi, where I runs from 1 to 22. Then, in order to compute the maximal set of compatible resolutions, we define a graph whose vertices are the resolution of Fi, and where two resolutions are adjacent if and only if they are compatible. So consequently, computing the, and I have a, how can I point it? Oh. Okay, so consequently, computing the compatible sets of maximum size reduces to, and I have a mistake here, sorry, to compute cliques of maximum size in this graph. And here are the results. So in the first column, I label the 50, well, I have two tables. One is the continuation of the other one. So in the first one, I label from F1 to F11, and then from 12 to F22. And in the second column, I compute the order of the automorphism of each design. In the second and the third columns, sorry, the third and the fourth column, I compute the parallel classes and the resolutions respectively. And finally, in the last column, I compute the compatible resolutions. So, as you can see, for all these designs, the compatible resolutions is just one, except from F17, which has 52 compatible resolutions. By the way, this to compute the parallel classes took me 10 days, or less, yeah. But yeah, finally I found that it has 52 compatible resolutions, and then the main term of the presentation is stated. Only one of the 22 one rotational 252-4-1 designs, namely F17, according to Professor Buratti and Suani paper, is embeddable as a maximal 52-4R in a plane of order 16, being the Sargisian plane PG216. So that's it. Thank you so much.